You've heard the words thrown around everywhere, right? AI, machine learning, deep learning. A lot of times people use them like they're all the same thing, but they're not. And you know what? Understanding the difference is actually the key to getting what's happening in our world right now. So let's finally clear this up once and for all.
So what is the real difference between these three? I know, it sounds super complicated, like you need a computer science degree to get it. But honestly, the relationship between them is incredibly simple once you have the right picture in your head. And I've got the perfect way to think about it.
Okay, here's the trick. Stop thinking of them as three totally separate ideas. Instead, I want you to picture a classic Russian nesting doll. You know the one, you have the big doll on the outside, and you pop it open and there's a slightly smaller one inside, and you open that one and there's an even smaller one at the very core. Each one fits inside the other. Let's start by looking at the biggest, outermost doll. That biggest doll, the one that holds everything else, that's artificial intelligence, AI. It's the whole field, the big picture idea that started it all. Think of it as the giant umbrella that everything else we're going to talk about fits under. So AI at its core is really just any system that lets a computer mimic something a human can do. A great example? Think about those old school chess programs. It wasn't some genius computer plotting its moves. No way. It was just following a massive pre-programmed rule book. Literally, humans wrote down rules like, if your opponent moves their knight here, you move your pawn there. It looks intelligent, but the machine isn't really thinking. It's just following orders.
All right, so what happens when we crack open that big AI doll? Well, inside, we find our next layer. We find machine learning. And this is where things start to get really, really clever. Okay, and this is the absolute game changer. With machine learning, we take that giant rulebook from before and we just throw it out, gone. Instead of telling the computer exactly what to do, we just show it a ton of examples and let it figure out the patterns for itself. It's exactly like teaching a little kid what an apple is. You don't sit them down and explain stem curvature and shades of red. You just show them a bunch of different apples, and eventually, they just get it. The machine learns from experience.
Okay, but that's the big question, isn't it? The word learn sounds like magic. How does a pile of code and silicon actually learn anything? Well, it's not magic, but it does come down to a few really smart strategies. Let's look at a couple of the main ones. So first up, you've got what's called supervised learning. Just think of it like a computer in a classroom with a teacher. We give it a ton of data that's already been labeled with the right answers. We feed it thousands of pictures, each one with a little tag that says cat. And after seeing enough examples, it figures out what a cat looks like. But then you've got unsupervised learning. Now the teacher leaves the room. We just dump a mountain of messy, unlabeled data on the computer. Say, every single purchase ever made at a big store. And we just tell it, find something interesting. And it might come back and show us completely new groups of customers that we never knew existed. There's one more big one, and this one is super cool. It's called reinforcement learning. The best way to think about this is like training a puppy. An AI agent tries something, and if that action gets it closer to its goal, it gets a little treat, a digital reward. If it does the wrong thing, it gets a penalty. The perfect example is an AI learning to play a video game. At first, it's just mashing buttons, total chaos. But after millions of tries, it figures out that jumping over that specific pit gets it a point, a reward. And it just keeps doing that, trial and error, until it's better than any human could ever be.
All right, you ready? It's time to open up our machine learning doll. What do we find tucked away at the very center? This is it. This is the powerhouse, the engine at the core of the entire modern AI revolution. This is deep learning.
Now remember, deep learning isn't some totally new thing. It's a very specific, very powerful type of machine learning. And its secret weapon is something called an artificial neural network. And just like the name suggests, it's a system designed to work a bit like the web of neurons in our own brains.
So why the name deep? Does it sound kind of mysterious? Well, the reason is actually super simple and literal. It's all about layers. These artificial brains are built with layers of digital neurons stacked on top of each other. A simple network might have just a couple of layers, but a deep network has tons of them, sometimes hundreds. And it's that depth that gives it its incredible power to find patterns.
Let's just walk through an example. Say you show the network a photo of a face. The very first layer, the input layer, has no clue what it's looking at. It's just a jumble of pixels to it. But that layer passes its info to the next one, which might figure out how to spot simple things like edges and corners. The next layer takes those edges and learns to combine them into shapes like eyes and a nose. Each layer gets more and more abstract, building on the work of the last one, until the final layer puts it all together and says, yep, I'm 98% sure that's a human face.
And this really shows you the trade-offs. You know, traditional machine learning is awesome for smaller, neatly organized sets of data. You can often run it on a standard computer. But deep learning, it's a totally different beast. It is a data monster. It needs massive, and I mean massive, amounts of messy data, like the entire internet. And it needs serious horsepower from special computer chips to run. But, and this is the big but, the payoff is that it figures out what's important all by itself. No human has to guide it. The deep network just finds the patterns automatically.
Okay, so we've opened all the dolls. We've got the big concept of AI on the outside. Inside that, we have machine learning, which learns from data. And at the very core, we have the powerful engine of deep learning. So why does this tiny innermost doll matter so much right now? The answer is, well, it's everything. That little doll at the center, deep learning, it is the absolute rocket fuel powering this massive explosion in generative AI that we're all living through. All those chatbots that can write poetry, the image generators that create incredible art out of thin air, yep, that is all being driven by this one core technology. So let's boil it down. Why is this such a big deal? It's because deep learning's ability to find these super subtle patterns in huge amounts of information is what unlocks these almost magical results. It's the reason an AI can actually understand the meaning behind your words or create a brand new image from a description. This innermost doll is literally the technology that is reshaping our world as we speak. So there you have it. We've opened the whole nesting doll, from the big idea of AI to the cleverness of machine learning, right down to the brain-like networks of deep learning at the core. The relationship is simple, but the potential is just staggering, which leaves us all with the most important question. Now that we understand how it all fits together, what are we going to build with it?